I'm going to tell you what the Pythagorean theorem is and what you can do with it. Pythagorean theorem is basically a formula for finding the missing side of a right triangle. Pythagorean theorem only works with right triangles. That is a triangle with a 90-degree angle. So if you want to use the Pythagorean theorem, you must have a triangle which has a 90-degree angle, such as the one we are looking at right here. So this triangle ABC is a right angled triangle. And we also know that this side A, that is opposite the angle A, is 3. And this side, the side B, that is opposite the angle B, is 4. And this is the side C, and we want to find it. It's the missing side. So how do you find it? The Pythagorean theorem basically tells us that a squared plus b squared equals to c squared. And this is a very useful formula for finding the missing side of a right triangle. But what you need to keep in mind is this side C is the longest side of the triangle, the side that is opposite to the 90-degree angle. So let's put the values into this formula. We know that a is 3, so instead of a squared, we write 3 squared. And instead of b squared, we write 4 squared. And that equals to c squared. We're going to leave c as it is, because we do not know its value and we're actually trying to find it. So in the next step, let's find what 3 squared is. 3 to the power of 2, or 3 squared, is 9. Plus 4 squared is 16. And that equals to c squared. Now let's add 9 and 16. It makes 25. So we now know that c squared is 25. Now in the next step we need to take the square root of both sides, because we want to get rid of the c squared and we want to get c. So let's take the square root of both sides. And on this side we get 5 equals to, and on the right hand side we get c. So what we've got is c equals to 5. So there we are. We found the answer. We found the value of the missing side, c. c is 5. So here is another example question. This is the triangle A, B, C, and angle C is 90 degrees. So we know this is a right triangle. And side A is 5. And side C, the side opposite the 90-degree angle, the longest side, is 13. And this is the side B, the side that we're trying to find. And how do we find this? Again, we'll use the Pythagorean theorem, but in a different order. So let's put our values into the formula. We know what a is. A is 5, so we write that and we take its square. We do not know what the side B is, so we'll write b squared and leave it as it is in the formula. B squared equals to 13, which is the side C, the longest side, and we take its square too. So in the next step we find the square of 5. 5 squared is 25. We still don't know b squared. It's the side we're trying to find, so we leave it as b squared. And 13 squared is 120. 69. Now we take 25 to the other side of the equation, and when we do that, it takes the opposite sign. So on this side, when it was here, 25 was plus, it was positive 25. When it goes to the other side, it becomes minus 25. So that's what we get. 169 minus 25. Let's continue over here. What we get from that is b squared equals to 144. Let's take the square root of both sides to find b. The square root of b squared is b, and the square root of 144 is 12. So there we are. We used the Pythagorean theorem again to find the missing side of a triangle. And this time we didn't find the longest side. We found one of the shorter sides. The side B is 12. Now let's take a look at this triangle. This one is also a right triangle, and angle C is the right angle here. It's 90 degrees. Before we go on to solve this question and find the side A, I want to tell you something about the names of these sides. So, in a right angled triangle, the shorter sides, the sides that are not opposite the right angled, are called legs. So, sides A and sides B here are legs. And side C, that is the longest side, the side opposite the right angle, is called the hypotenuse. So there's a special name for this longest side, which you definitely need to keep in your mind. Now that we have learned this, we can go on to solve the question. So we do not know what a is, and we're trying to find a actually. So let's write a squared. We know what b is, it's 24. So instead of b squared, let's write 24 squared. And instead of c, we write 25 squared. So in the next step, we keep a squared as this. 24 squared is pretty hard to calculate, so this could take some time, but I'll do it for you. So I did the math, and 24 squared is 576. I hope this is correct, because I didn't use a calculator or anything, and I didn't even use a paper or anything. I just did it in my mind. So I really hope it's correct. And 25 squared is 625. That was somewhat easier to calculate. Let's go over here to do the next step. And in the next step, let's keep a squared over here, and let's move 576 to the right side, and it becomes minus 576. So when we subtract 576 from 625, we get 49. And let's take the square root of both sides to find a. And it turns out a is 7. So there we are. Again, we used the Pythagorean theorem to find the missing side of a triangle. We were looking for the side A, and we found it. It's 7. Practice makes perfect, so let's do one final example on how to use the Pythagorean theorem to find the missing side of a right triangle. In this example, the side A is 8 and the side B is 15. Let's start putting these values into the formula. It's 8 squared plus 15 squared equals to c squared. By this time we should have a good grasp of the Pythagorean theorem, so I am doing this faster than the previous examples. 8 squared is 64 plus 15 squared is 225, and the sum of those two equals to c squared. When we add 225 to 64, we get 289, and that equals to c squared. Now let's get the square root of both sides. The square root of 289 is 17. And on the other side, we have c. So that's it. We found the answer using the Pythagorean theorem. We were looking for the missing side, side c, and we found it. c is 17. If you found this video useful, you can also take a look at my other videos on the Pythagorean triples and the ways to use the Pythagorean theorem to easily find the missing sides and the area of different types of triangles. Have a good day.